Okay, here's a question that refers to the conjugate of complex numbers. Show that the product of w and z conjugated equals the conjugate of w times the conjugate of z for all complex numbers w and z. So in order to conjugate, let's just agree that we have to write things as their real and imaginary part. So let w equal a plus bi, z equal c plus di. You can do that for any complex number with a, b, c, and d reals. Okay, so let's just trace our way through this. Okay, the left side says w, z conjugated. So order of operations says I'm supposed to do wz first. W equals a plus bi, z equals c plus di. So multiplying all of those things, and I'll worry about the conjugation later, I get a c plus a di plus b ci plus b di squared. Remember, I squared is -1, so really what I have is I have a c minus bd plus, that's my real part, plus ad minus bci, and all of that is conjugated. So this part, I should have had that bar all the way out. That's conjugated, okay? What does conjugation mean? It means you do absolutely nothing to the real part, but you change the sign of the imaginary part. Now, I could just as soon have my negative distributed, but I'll just, for emphasis, I'll put it right there. That's what conjugation does. Now let's see if we can anticipate how many lines this is going to take, because it's probably most obvious if we sort of start at the other extreme. So let's see. If we said, okay, down here I'm going to have w conjugate times z conjugate, and then this is the conjugate of a plus b. Maybe I need an extra line there. Let's say one more line down. I want to end this proof saying w bar times z bar, w conjugate, z conjugate. Well, what's the conjugate of a plus bi and the conjugate of c plus di? Well, the conjugate of this is just a minus bi, and the conjugate of this is just c minus di. So let's see what happens if I multiply those out. I get a c, then I get minus ADI. Here I get minus BCI. And here I get what? Plus BDI squared. Okay? Well, perhaps you can believe that these terms are actually equal. We have an AC term, I have a negative BD term, I have a negative AD term, and what happened here? I have a typo. In this line, I should have had this be a positive BC, so that distributes and I get a negative BC. So now, the goal of a proof, when it says show that, that means that this is a proof, is you should be able to not just watch the video, but you ought to be able to read what's on the paper and believe it going left to right. So w times z conjugate is equal to that, okay? That is equal to this simply by distributing each term. This is equal to the next term by gathering the real part and the imaginary part. Then when I apply the conjugate, I simply change the sign on the real coefficient. Here, I've just reordered these terms. That term is there. This term is over there with an I squared. this term and this term have a negative sign. I've distributed the negative sign. Then I've factored that into 2 parentheses. Well, but these are just the conjugate of a plus bi and c plus di, and that's w conjugate times z conjugate.